So let's take a look at section 2.4 again. If you look in Canvas, there's an additional set of guided notes that go along with this section. I'd go ahead and print this one out because we're going to be doing a little bit of graphing, and the graphs are provided for you on the paper. So just some extra practice, some extra examples to help support linear functions. Like I said earlier, this is a really, really important topic. So I want to give you as many examples as you can on this. So the first question, it asks us to find the slope of each of those lines. And so essentially all we're going to do is we're going to use rise over run. So any 2 points on the line will work, but you want to start from a point towards the left and work your way towards the right. So let's say we start down here at this point that they gave us. They didn't put any numbers on this graph, they really should, but we'll assume this is at -1, 2, 3, 4, 5. So the y value there is -5. And then 1, 2, 3, 4. It looks like it's 5 by 5. So I think this ordered pair is -5, -5 is what it looks like to me. And then this point up here, it looks like is at -1, 4. One way you could do this is actually obtain the points and use the slope formula, but you could also just draw it. So if I take this point and I have to go up because it's a positive slope. So we're going to go up all the way to the top, all the way to that where that line is in line, that point rather is in line with where I'm going to stop at, and then over. So it looks to me like we've got a rise of 9 units. So everybody see how I got that? I went up 5 and then up an additional 4. And then a run over here of, it looks like, let's see, 1, 2, 3, 4 units. So our slope here is going to be a positive 9 over 4 using rise over run. Let's look at the next picture. So we've got a point here, and then we've got a point here. You want to start on the one furthest to the left. So from here, because it's got a negative slope this time, I'm going to go down until I'm in line with the other point. Looks like it's right about there. And then we're going to run, always run to the right. So I went down, let's see, 1, 2, 3, 4, 5, 6, 7. So that's going to give me a vertical change of -7. And then to the right, 1, 2, 3, let's see, 1, 2, 3, 4, 5, it looks like 6. So our slope there is going to be -7 over 6, but make sure you see it was negative because we had to go down. Always make sure your slopes match what the line is doing. If the line is increasing, it needs to be positive. If the line is decreasing, it needs to be negative. Let's look at the next question. It says, find the equation in slope-intercept form of the line that is parallel to the given line and contains the point -1. Whenever you're asked to write the equation of the line, the first thought that should come to your mind is, I need to get a slope. So if I need my line to be parallel to the given line, I need to find the slope of the given line. And then what do we know about lines that are parallel? Remember that their slopes are the same. So let's take this line. I'm going to rewrite it down here just so it's a little bit bigger. And to get the slope of this line, I need to put it in slope-intercept form, which means I need to rearrange it and solve it for y. So I'm going to move the x term to the other side first. So I'm going to add 2x. So those go away. So I have -3y equals, and I'm going to write the x term first, 2x plus 12. And then divide by -3. Everything gets divided by -3. So my equation here, those go away, is y equals -2/3 x. And then it's 12 divided by -3, so -4. So my slope from that line is -2/3. So my line needs to contain the same slope because it needs to be parallel, but it needs to now go through this point. So let's come over here. And we know our slope is going to be -2/3. We always start in point slope form. So I'm going to have y minus 9 equals -2/3 times x minus a -1, so plus 1. They asked us to write it in slope-intercept form, so I'm going to distribute the -2/3. So I have y minus 9 equals -2/3 x minus 2/3. And then I need to get that 9 over to the other side. So I'm going to add 9, add 9. I have to get a common denominator here. And sorry, this is a little bit messy. So I'm going to kind of off to the side, I'm going to do -2/3 plus 9. That's 9 over 1. I need to get a common denominator here. So the common denominator would be 3. So I'm going to multiply by 3 here. So that gives me -2/3 plus 27/3, which gives me 25/3. So that's going to be my y-intercept. So let me come back to the equation. Remember, it was up here. So it's going to be y equals negative 2/3 x plus 25 thirds for the y-intercept. And that's going to be our answer for the equation that's parallel to the given line and in slope-intercept form. Okay, let's take a look then at example 3. All right, so it says find the equation in slope-intercept form for the line perpendicular to the given line and containing this point. So again, first thought should be I need a slope. What do I know about lines that are perpendicular? Their slopes are opposite reciprocals. So I'm going to take the given line and I need to get the slope from it. So I need to get the y by itself once again. So I'm going to add the x to the other side. So I get 2y equals positive x plus 7. And then we need to divide by 2. Now, what is the coefficient on the x? If there's nothing written there, it's an implied 1. So the slope from the given line is 1/2. Now, I need perpendicular, so that means that my slope needs to be negative 2/1. Flip it and change the sign. So let's write the equation of the line in slope in point slope form first. So we're going to have y minus y1, which is the negative 2. So y plus 2, and the negative 2 I'm using is the point, negative 2, equals m, which is the slope, negative 2, times x minus 5. They want the answer in slope-intercept form, so this one's a little bit nicer because there's no fractions to deal with. I'm going to distribute the negative 2. So I have y plus 2 equals negative 2x plus 10. And then I'm going to subtract the 2 to the other side. So I get y equals negative 2x plus 8 is going to be my final answer. Okay, let's take a look at example 4. It says to identify the slope and the y-intercept for the given line. This isn't too bad. We've been doing this anyway. I just need to rearrange this and put it in slope-intercept form. So I'm going to subtract the 4x first. I always like to write that 4x term first on the right side. So I have negative 3y equals negative 4x plus 6. And then we're going to divide by negative 3. Everything gets divided. So then I have, let me write it over here, I have the equation y equals negative divided by negative 4/3 x and then minus 2. So the slope would be what? 4/3. The y-intercept is the b value, so that would be negative 2. Okay, and as an ordered pair, if they wanted me to write it that way, I'd write 0, negative 2. Okay, example 5, it says to find the equation of the line. And they gave you two characteristics of the line, that it has an x-intercept of negative 4 and a y-intercept of 3, and they want the answer in standard form. Okay, so let's go ahead and start by writing down those points. So remember, the x-intercept and the y-intercept, those are points on the graph. So let's write those as ordered pairs. So we're going to have an x-intercept of negative 4 means the ordered pair would be negative 4, 0, and the y-intercept of 3 would be 0, 3. So I could have given you this question and said, here's 2 points, write the equation of the line. The process is the same. You just had to come up with the points based on what they gave you. So again, what's the first thing I need? Anytime I write the equation of the line, I need the slope. So if I have 2 points to find the slope between them, I'm going to use my formula, y2 minus y1, so that'd be 3 minus 0, over x2 minus x1, so that'd be 0 minus negative 4, which gives me a slope of 3/4. Now, we need to write the equation. Remember, you can pick either point. It does not matter. I think the point with the y-intercept might be a little easier to work with, but it really makes no difference. So let's start with that. So I always write with point slope form to start off. So we're going to have y minus 3 equals 3/4 times x minus 0. And of course, that's just x. So that gives me y minus 3 equals 3/4 times x. We're going to add the 3 over. If they had wanted the answer in slope-intercept form, we'd be almost done, because here it is, y equals 3/4 x plus 3. But they wanted it in slope-intercept, I'm sorry, they wanted it in standard form. So let's practice that. So let me come over here. I've got a little more space. So let me write it again. We've got y equals 3/4 x plus 3. Here's where we're at. So to be in standard form, remember the x and y have to be on the same side, and there can't be a negative in front of the x, and there can't be any fractions. So since the x is positive the way it is, I'm going to leave it where it's at, and I'm going to subtract the y to join the x on the right side. So that gives me 0 equals 3/4 x minus y plus 3. Now, how am I going to get rid of the fraction? Well, remember in chapter 1, very beginning of chapter 1, we talked about rational equations, clearing the fractions. Meant we multiply everything up there by something that will get rid of the denominator. So in this case, the denominator is 4. So if I multiply everything by 4, we should be good to go. So everything, and I mean everything on both sides. So we're going to multiply by a 4 over here, a 4 here, a 4 here, and a 4 here. I probably didn't need those parentheses. I like to write the 4 in front of all the terms. So 4 times 0, of course, is 0. The 4 and the 4 cancel with the x, so that's 3x. Minus 4 times y would be 4y, and then 4 times 3 would be positive 12. And there's my equation in standard form. Example 6, it asks us to sketch these lines. So we've got two graphs here. The first one is in slope-intercept form. When it's in slope-intercept form, I would start by plotting the y-intercept and then doing rise over run. So the y-intercept for picture A is 4. So we're going to go up here to 4. And then since the slope is negative from that point, I'm going to go down 2 units. So 1, 2, and I always run to the right. So 1, 2, and then run to the right. 1, 2, 3. There's my second point. There's my line. If you're doing these in my math lab, there's usually a little graphing tool. Just make sure you get those points in the right spots. The second one, we could rearrange it and put it in slope-intercept form, but this might be a good option to do the intercept method we talked about in the last PowerPoint. So I'm going to find the y-intercept by replacing x with a 0. So if I do that, I get 2 times 0 plus 5y equals 10. So I get 5y equals 10. Divide by 5, I get a y-intercept of 2. Had we rearranged the equation, we would have gotten that same point, y equals 2, y-intercept of 2 would have been our b value. This is just a shorter way of doing it, I think. And then, so on the graph, let me come to the y-axis and put a point at 2. For the x-intercept, remember we're going to let the opposite variable equal 0 when we get intercept, so I'm going to let y equal 0. So we're going to have 2x plus 5 times 0 equals 10. So I get 2x equals 10. Divide by 2, I get an x-intercept of 5. So I'm going to go over to the x-axis. I'm going to put a point on the x equals 5. I've got my 2 points now, and I can write or draw my line. This intercept method, I think, is good when you don't get fractions. So if you can see, like 10 was divisible by both 2 and 5. I knew that was going to happen, so I figured, okay, let's get the intercepts because we won't have any fractions. If that number on the right side, that c, that constant, is not divisible by either of these terms, then it might be better to rearrange it and put it in slope-intercept form and do it the same way we did the first graph. Okay? Let's take a look at example 7. It says write the equation of the line containing the point 2, 4 and perpendicular to the line x equals 5. So I brought this up to just remind you what x equals 5 is. Remember, that's a vertical line that goes through 5 on the x-axis. So think about, I didn't include a graph, but we can make a quick sketch of this. X equals 5 would be over here as a vertical line. So if we want a line that's perpendicular to it, think about what kind of line that would have to be. So if it's perpendicular to a vertical line, then it would have to be what kind of line? And hopefully you're thinking horizontal, right? It has to be horizontal if it's perpendicular to that. So it's got to go through the point 2, -4, which is down here. So we just need something at that location that's perpendicular, which is horizontal. So it would have to be the line y equals what? What's the y value that it has to go through? -4. You could have done this without drawing the graph as long as you thought to yourself, okay, this is a vertical line, so perpendicular to it would have to be horizontal. So then it would have to be y equals whatever this y coordinate is. Now let's do number 8. It says containing the point 2, -4. So it's the same point, but this time they want it parallel to the line x equals -1. So visualize that in your mind. X equals -1 would be what kind of a line? So that would be a vertical line. So any other line that's parallel to it would also be vertical. So we're going to go ahead and I'm going to make a sketch just so you can see what I'm talking about. X equals -1 would be over here, vertical line like this. So again, we want it to go through the point 2, -4. And then it needs to be parallel. So it also has to be a vertical line. Well, what's the equation then for a vertical line? It's going to be x equals, and then what x value is that going to go through? Has to go through 2. X equals 2.